Okay, in this video I will be solving problem set 2, problem 1. And before I start trying to derive my code words, I want to go back over the theory a little bit so I can answer these questions. Matter of fact, I don't need to do solve for k or code C before I do this. So I'm going to solve this part first, and I'm going to do that. I'm going to go onto a separate sheet of paper. So the way to know that you can detect or correct an error is basically by knowing how close or far you are from an actual word in the code. So, for example, if I start off with a distance 1 code, imagine that this line segment and any future line segment is a distance of 1 between two code words. So, we have code word 1 here, and it is code 0 and code word 2, which is 1. If I change one bit, I switch from this code to this code and back and forth. And this is true for any distance 1 code. So with this, if I change one bit, I'm at another code word. So I can't detect that an error has occurred because I'm at a valid code word regardless of whether or not an error has occurred. So here I detect 0, correct 0, because I can't correct if I can't detect. So let's move on to a distance 2 code. So this was distance 1, distance 2. We're going to do the same thing, except now we're going to have 2 line segments. We'll make it 0, 0, and 1, 1. And now if I change one bit, I'm not at a valid code word. I've switched to here, which could be, let's say, 0, 1 or 1, 0, but I'm not at a valid code word. So I know that an error has occurred because I'm not at either one of these endpoints. So I can detect that one error has occurred, but if 2 errors occurred, I'm at another valid code word, so I can't actually detect any more. So, but can I correct? Well, this is a harder question to answer because, while I can detect that I have an error here, can I reliably get back to the correct code word? Well, seeing as I'm equidistant from C2 and C1, it is just as likely that I came from here as that I came from here. So we find out that we can not correct any errors at this point. And let's hope that the correction might make more sense after we do step 3 when things look a little different. So here we've got code word 1, code word 2, and I'm going to stop giving example code words because they're going to become redundant. They basically just keep adding zeros and ones onto this. So if I have a 1-bit error, I'm not another valid code word, so I know that an error has occurred. If I have a 2-bit error, I'm still not at a valid code word, so I know that an error has occurred, so I can detect up to 2. And for correction, I look at this. If I have 1-bit error, I'm twice as close to my original code word as I am to the wrong code word. So if I make a mistake of 1 bit, it's twice as likely that this is the correct code word as this is in my mind. And so I'll actually correct to the correct code word. However, if I have a 2-bit error, I've gone 1, 2, if I try to figure out which one is the more likely, I'm going to pick this one because it's twice as likely as this because it's twice as close. So in this case, I can only correct 1 bit of error. And then, so for distance 4, we've got a similar thing. Now we've got this, C1, C2. 1 bit of error is fine. 2 bits of error, 1 bit of error, I can detect an error. 2 bits, I can detect an error. 3 bits, I can detect an error. But how many can I correct? So obviously I can still correct 1 because now if I have a 1-bit error, it's 3 times more likely that it came from the correct code word than it came from the wrong code word. But if I move to the 2nd bit here, the problem is that now I'm equidistant from C1 and C2. I don't know which one's more likely. If I made a mistake and I get to here, I don't know which code is more likely. So I can't correct a 2-bit error. So it's still only correct one. Now for distance 5 code, see if I can somewhat evenly divide this. Oh, that looks decent. We have code word 1, code word 2, and you've seen the pattern before. Now this is detect 4, because there's 4 tick marks basically in between. And we've got if we're trying to detect errors, we've got 1, 2. We know 1's going to work because this is now 4 times more likely, and 2. So this is 3 away, this is 2 away. 2 smaller than 3, so I can reliably get back to the correct one. If I have 3-bit error, this is 3 away, 2 away. This would be closer to C2, and I would incorrectly, quote-unquote, correct to C2. So I can, at max, correct 2 errors. So I'm going to fill in the table now with this information. So at distance 1, I have 0, 0, 1, 0, 2, 1, 3, 1, 4, 2.